But anyway, now for our feature presentation, our speaker, we have Ahmed, and I'm definitely going to butcher the last name. Tikiwa. We'll just go with that. He's a seasoned full stack developer with 10 years of experience, strong passion for developing world-class applications that can make a difference. His experience in both front end and back end, built enterprise solutions for telecommunications. He's currently a senior Android engineer and a tech lead at Luno and GDG Cape Town, where he's a co-organizer. An official contributor to the Google Developers Dev Library. So, without further ado, I'll let our speaker take it away.
Hey, everyone. Okay, so let me just share my screen. Alrighty. Okay, so my talk, from XML to Compose, my journey of transforming an existing Android large app to Jetpack Compose. I'm Ahmed Tikiwa. I am a senior software engineer at Luno. I specialize in Android. And yeah, so I'm based in Cape Town in South Africa. And a fun fact, I'm actually talking to you from the future. It is actually Friday, 2 a.m. right now. Yes, so hello from the future. Okay, so first question, why Compose? So most Android development, including my own, included defining layouts using at least one XML file. This XML file would contain a tree of UI widgets constituting an Android view hierarchy. If the user interacts with the screen, for example, this would result in a change in the app state, and thus a need for the UI hierarchy to be updated to display the current data representing the change state. However, to update the UI, a function such as find view by ID is used to go through the hierarchy tree, and then the internal state of the node, which is the UI widget, is updated through functions like setText or addChild. This manual change of the UI widget is very error prone. For example, trying to set a value to a node that has already been removed from the UI, thus resulting in an unintended exception. The more views that are part of the application, the higher the level of maintenance and complexity. So Jetpack Compose was created with the intent to simplify the above and instead accelerate the way in which we develop our UIs using less code and benefiting from a list of powerful tools all in Kotlin. In other words, no more XML-defined views, which is referred to as the imperative approach. Rather, views are now defined in the Kotlin code, referred to as the declarative approach, meaning you now describe your UI. So what are other companies saying about Jetpack Compose? At Monzo, they're saying it's much easier to trace through code when it's all written in the same language, that language being Kotlin, and often the same file, rather than jumping back and forth between Kotlin and XML. At Twitter, they're saying our theming layer is vastly more intuitive and legible. We've been able to accomplish within a single Kotlin file what otherwise extended across multiple XML files that were responsible for attribute definitions and assignments via multiple layered theme overlays. So when was Jetpack Compose introduced? I first heard about Jetpack Compose when it was announced as a preview by Google at I/O in 2019. And this is what one of the people on the team had to say about Jetpack Compose at the time. One of the areas we never solved was UI. We really wanted to look at how could you make it super simple to develop UI. This was Karen, a group product manager at Google. Then Leland Richardson had these thoughts. What I think is once people start seeing Compose in action, it really becomes a delightful thing to program. So like any developer, I was excited as I was already using Jetpack Compose libraries extensively as part of my development, with a new one being added to further accelerate or speed up my development with even less code. Even though I was excited, I was also trying not to feel overwhelmed at the prospect of learning a whole new way of writing UI, as the declarative approach, rather the imperative approach, is what I was used to for years. And due to time constraints, I also delayed learning Jetpack Compose until recently. So, learning Compose. I started learning Compose through the course on the Android developers website, which takes you through step by step into understanding the inner workings of Compose, from thinking in Compose, the basics, navigation, theming, animation, integrating into existing apps, all this through articles, videos, and code labs. The course also has a short quiz at the end to test your understanding of Compose and includes a Jetpack Compose badge, which will be added to your developer profile on successful completion. So in addition to this, as I'm a visual learner and with a desire to thoroughly understand Jetpack Compose, I went through 2 paid Jetpack Compose courses on Udemy. This approach is, of course, totally optional, but the extra visual tutorials helped me. The first was a short course by Kotlin Gita, Jetpack Compose crash course for Android with Kotlin. And then the second, and a more extensive course by Paolo De Shorne, which covers the Kotlin fundamentals, which is the Android Jetpack Compose, the Comprehensive Bootcamp 2022. For those who need either a refresher or are new to Kotlin, and a series of different apps to help solidify the Compose concepts and how all the components fit together, coupled with state management. Then once I was done with my learnings mentioned above, my desire was to now implement Jetpack Compose into my existing Android app, Up Next TV Series Manager. Up Next is an app I created in 2015 as a passion project of mine and has been in production since and is available for download from the Google Play Store. It is also open source and officially part of the Google Developers Dev Library. The app boasts the following screens: a dashboard screen showing a schedule of shows that aired the previous day, the current day, and the next day, provided by the TV Maze API. A search screen allowing the user to search for shows with the results displayed in a clickable list of cards with data provided by the TV Maze API. An explore screen showing the currently popular, trending, and most anticipated shows provided by the Trackit API. A show detail screen showing a summary of the show, cast information, a rating breakdown from Trackit, previous and next episode information provided by TV Maze and Trackit APIs. Then it also has a list of seasons for a particular show displayed in a list of clickable cards with data provided by the TV Maze API. Then there's a list of episodes for a particular season displayed in a list of clickable cards with data provided by the TV Maze API. And finally, there's a Trackit account screen, which displays one of 2 screens, depending on whether the user is logged in to their Trackit account or not. If the user is logged in, then their list of up next favorited shows will be displayed. Adopting Compose, choosing the approach. What makes Jetpack Compose so powerful is that it caters not only to developers creating new apps, but also to developers who have existing apps and would like to include Compose into it. What makes the latter a possibility is the concept of interoperability. What this means is that Jetpack Compose code can live side by side with XML-based code. With that said, adoption can be done in one of 2 ways, according to the Android developers website. The bottom-up approach starts by migrating the smaller UI elements on the screen, like a button or a text view, followed by its view group elements until everything is converted to composable functions. Then we have the top-down approach, which starts by migrating the fragments or view containers, like a frame layout, constraint layout, or recycler view, followed by the smaller elements on the screen. So what does interoperability look like? Each of my fragments has an XML layout view associated with it. Some screens also have an additional layout view for recycler view items used by the respective recycler view adapter. And as this is a gradual migration to Compose, where I'm going screen by screen, I'll be completely removing fragment files in the future and have Compose navigation, where the navigation will be from composable screen to composable screen, as opposed to the current fragment to fragment navigation. Compose view makes it possible to introduce Compose UI content into an existing XML layout. The Compose view acts as a container to host the Compose UI content, thus making it possible for Android views to coexist with Compose UI in the same XML file. So continuing on with what interoperability looks like, this is how my fragment now looks. So I removed all the Android views, text views, recycler views, nested scroll view, constraint layout, linear progress indicator, and replaced all of that with Compose view. Once the app makes use of Compose navigation, then the need for Compose view will become redundant. Then in my fragment, using data binding, I reference the Compose view in order to set it up. So as you can see there, binding.compose container.apply. So using data binding, I'm referencing the Compose view within my fragment. Then according to the documentation, by default, whenever the view is detached from the window, Compose disposes of the composition. So Compose UI view types such as Compose view and abstract Compose view use a view composition strategy that defines this behavior. To ensure unintended behavior and to ensure that compositions are disposed of automatically when not needed, then set view composition strategy is required. Without this, my app crashed as I navigated between the composable screens. The set content takes in a composable function as a parameter, in this case, the theme definition, MDC theme, which also takes another composable function, in this case, the composable screen, which I created called search screen. Now, MDC theme is part of the MDC theme adapter, which is a library or a dependency which I included into my app, which allows me to leverage Jetpack Compose material design into my app. So when it comes to having material design within the app, there's a certain way that you need to create it. There's a certain way you need to define your styles, your themes, and all of that. It's now different where you, before, the way it was defined before, now you create Kotlin classes as part of that. So now MDC theme takes your existing legacy theme or imperative theme and transforms it into Jetpack Compose, which is very nice. So when you are then ready to now fully use the Jetpack Compose material design, you can just create it and do away with the MDC theme adapter. So breaking down the changes, starting off with the search screen. My focus on the search screen was the following: updating the search bar to be a composable, updating the search results list where I create a composable representing a single result item and then displaying the list of these single result items or composables representing a search result item. Then I will then remove the recycler view adapter, its view holder, and item layout. Then this is how my composable now looks. So this is search screen. So this is how I created the search screen composable, which is a function annotated with @composable, as you can see there. However, what is a composable? So Jetpack Compose is built around composable functions. And within these functions, you define your app's UI programmatically by describing the UI of your app, how it should look. And you also provide the data necessary to be displayed. You therefore no longer have to focus on the process of the UI's construction, such as initializing an element, attaching it to a parent, and so forth. So for my composables that represent an entire screen, I like to add screen as part of the name. Also notice that the composable function begins with an uppercase. This is a noun. So using the Pascal case. Then for dependency injection, I use hilt in my app, and because my view models are hilt view models, I can pass hilt view model to allow my view model to be provided here. The hilt view model call is part of the hilt navigation compose dependency, which I added to my app. Then, because the data in my view models is currently being returned as live data, I can transform that live data value into state using observer state. Then every time there would be a new value posted into the live data, the returned state will be updated, causing a recomposition of every state.value usage. Now, composables rely on state, which is why I'm transforming this live data into state so that the composable can react on the state and decide whether it will recompose or not. Then when I migrate up next navigation to the compose navigation, I will then use the scaffold layout, which automatically provides slots for the top bar, the bottom bar, and other slots as well. So for now, a surface layout with a modifier as fill max size to occupy the whole screen will suffice. Then composables can take a modifier, which is a companion object that can help you define properties such as padding or clickability and more. It is one of the most handy tools that you'll be using a lot within Jetpack Compose. So in this case, my modifier is defining fill max size. So that surface there is going to occupy the entire size, which is the entire width and the entire height. Then the column composable arranges the composables contained inside it to be arranged vertically on the screen from top to bottom, as you can see in the illustration there on the left. Then I want to add a linear progress indicator, but in order to ensure that the list does not jump or shift position on the screen when the linear progress indicator is removed from the screen, I rather want to display the linear progress indicator on top of the list. That way, when it disappears, the list remains in its position. To achieve this, I use a box composable, which is the equivalent of a frame layout in the imperative approach. The box composable allows views to be on top of each other, as you can see in the illustration there on the left. Then inside the box composable, I have my custom composable called search area. Then as well as the linear progress indicator, which is only displayed if the is loading state is true. So this is where the state that I was referring to earlier comes into play. So that state variable is loading will then determine whether that composable is then recomposed or not. So before I explain what's going on here, one concept is very important when it comes to composables. There is the concept of state hoisting, which is the process of moving state all the way to the caller, in that way ensuring that composables are as stateless as possible, which is the recommendation. In my case, the caller, which is my screen composables, and the composables below it need to hoist the state up to it as much as possible. There are times when state hoisting isn't always possible. However, it is best practice to make composables as stateless as possible. If a composable has got state in it, it's called stateful, and it is recommended to be stateless. As a general rule of thumb, state comes down the composables and the events go up. So when composables are stateless, it also makes them easier to reuse as well as test. So my search area composable will represent the text field for entering the search query as well as the search results. It accepts 3 parameters: the search results list, 2 function arguments on text submit and on result click. These are events that the composable will respond to and hoist up the responsibility to the caller of search area, in this case, search screen, so all the way to search screen, to decide what to do with that event. Then on text submit will be invoked when the user has entered a search query. This event is hoisted up from the search form composable all the way up to search screen. Then on result click is an event invoked when the user clicks on one of the search result items. This event is hoisted up from the search results list composable all the way up to search screen. So here's what the search form composable I created looks like. So there's how I'm calling it there, and on the right-hand side is how I've defined that function. It has a mutable state variable called search query state. In order to ensure that this state survives the activity of process recreation using the saved instance state mechanism, I used remember savable. Now the user's query will be remembered in a state variable and survive configuration changes. My search form composable makes use of a search input field composable, which is a composable I created as a simple wrapper function around the material outline text field composable, which I will show in the next slide. The state variable, search query state, is then used in the input field. Initially, the value will be empty because it is initialized to an empty string. Then when the user types the value, the onValue change event is invoked and the search query state value is updated and remembered. So here's what my search input field composable looks like. So on the left-hand side is where I'm calling it, and on the right-hand side is how I've defined it. As you can see, it calls the material outline text field composable, passing it the input label, the value state, which is a mutable state variable of type string. And when the outline text field's on value change is invoked, then that event is passed up, state hoisting, containing the new value of type string. My search results list composable takes two parameters, the list to be displayed and a function argument, which will be the on-click event containing the search result item. So on the left-hand side, this is how I'm calling it, and on the right-hand side is how I have defined it. So search result list composable then makes use of the lazy column, which is the equivalent of the recycler view, but more powerful under the hood. Also with this, there is no requirement for adapters, view holders, and so on, which is brilliant. Lazy column and its other counterpart, lazy row, simply take a list and inside the lambda, referred to as the lazy item scope, and define which composable represents the column or row for that list, similar to when you would create an XML layout for a view holder. This time, you just create a composable that represents that column or row. In the previous slide, where I showed the search screen composable, I didn't show the full implementation until I covered the above, in order to make things clearer first. So this is the full call for the search area composable, where a list is passed to it. And then when the search area composable's on result click event is invoked, search screen will then call the nav controller as part of the Jetpack navigation library to navigate to the show details screen. Before and afters, the fun part. So for the search fragment, the imperative approach, this is how it looked on the left-hand side there. Now you will see there's a top bar, a toolbar there, and then there's a search area there, and then there's a search results, then there's a bottom navigation bar. So my exercise for these particular screens was basically transforming the areas that are contained in between the toolbar and the bottom nav bar. Then my next part, the next part of my journey will be using the compose toolbar, using the compose bottom app bar, and so forth. So this is how it looks in Jetpack Compose. So it uses a composable, which I showed you earlier, called search screen. And so search screen represents my entire screen. And then inside search screen, I created search form, which I showed earlier, and then search results list to represent the list of results that are shown there. As you can see, using different composables to represent different sections of the screen. This will make things easier to read, to test, to maintain, and so forth, as long as you make sure that you've got very minimal composables. Then my dashboard fragment. This is how it looked on the left-hand side using the imperative approach. And this is how it looks using Jetpack Compose. So for the shows that aired yesterday, airing today, and airing tomorrow, I use a composable I created called shows row, which uses the lazy row composable, which is a built-in composable as part of Jetpack Compose. Lazy row allows you to have a list of scrollable items from left to right. And I was able to use same shows row on the component below it, as well as below that as well. Then the explore fragment, this is how it looked on the left-hand side using the imperative approach. And this is how it looks using Jetpack Compose. So the explore screen is now the representative of the entire screen. And within it, there are various composables, in particular trending shows row, which represents the trending shows, popular shows row, and then most anticipated shows row. And all of these use the lazy row, which allows me to have a scrollable list going from left to right. Then the show detail fragment. This is how it looked on the left-hand side using the imperative approach. And this is how it looks using Jetpack Compose. So using Jetpack Compose, so show detail screen is the name of the composable representing the entire screen. And then the area where you see the backdrop image, the wide image there, as well as the title and the status of whether it's running or ended. I created a composable called backdrop and title. So that represents that top part there. Then I created a composable called poster and metadata representing that little poster, as well as the metadata information, when it's airing, the genres and the attribution information. Then I use the built-in text composable to basically use to render the synopsis of the show. Then continuing on with the show detail fragment. So this is now below the synopsis. So on the left-hand side, this is how it looked using the imperative approach. And on the right-hand side, this is how it looks using Jetpack Compose. So the buttons, I created a composable called show detail buttons representing buttons that will form part of this screen. So currently I have a seasons button as well as a favorite button. So allowing you to add or remove the show from your favorites. The season buttons now takes you to the seasons screen. Then below that, I've got the cast information, and I created a composable called show cast list, which also uses the lazy row. So the cast information is a scrollable list going from left to right. Then below it, I created a composable called previous episode, and below that, there will be next episode composable. These basically represent the previous episode information, the title, the synopsis, and so forth, when it's going to be airing. Then continuing on with the show detail fragment. So this is now below the previous and next episode information. This is how it looked on the left-hand side. And then this is how it looks now using Jetpack Compose. So I was able to create that ratings information using a custom component which I created called Track It Rating Summary. And I basically made use of the built-in linear progress indicator to create those bars there representing the scores of how many people picked a certain rating of 10 or 9 or 8 and so forth. Then I use the built-in text composables to represent the overall score as well as the views. And above that is the previous episode composable, as I mentioned previously, and above that as well will be the next episode one. Then this is the show seasons episodes fragment. This is how it looked on the left-hand side using the imperative approach. And this is how it looks right now using Jetpack Compose. So the entire screen is represented by show season episode screen, which is a composable representing the entire screen. And then for the titles, so season 5 episodes that you see there at the top, I created a composable section heading text, which I can then reuse across my app and just represent a section heading in a certain way. Then show season episodes is what represents my list there. And show season episodes uses the lazy column as opposed to lazy row, which was used by the previous screens. Lazy column allows me to have my list displayed from top to bottom in a scrollable list, vertically scrollable list. And then each item within show season episodes is represented by show season episode card. So that card there that you see there with season 5, episode 1, the new, all of that synopsis there, that is represented by show season episode card. And I pass that to show season episodes inside the lazy column, and the lazy column then renders that for me. No recycler views, no view holders and so forth, which is nice. Then the track it account fragment. This is how it looked on the left-hand side. So this is what it will look like when the users are actually logged into their tracked accounts on the app. Then on the right-hand side is what it looks right now using Jetpack Compose. So as you can see, I use the section heading text again on this screen to now represent that heading there, your favorite shows. And then I created a composable called favorites list, which uses a different type of lazy implementation, lazy vertical grid. So lazy vertical grid allows me to have a scrollable list in a grid format. And then each item within the lazy vertical grid is represented by list poster card. So each of those shows there is list poster card that's displayed there as part of the lazy vertical grid composable. Then the entire screen is a composable called track it account screen. So what still needs to be updated? As I mentioned previously, I'd like to update the toolbar to be a Jetpack Compose toolbar. I'd like to update the bottom navigation bar, migrate to Compose navigation, which I'm currently busy with actually. Then I'd like to remove all the fragment files. So once I've migrated to Jetpack Compose navigation, I no longer will need any fragments at all because all my screens will now be composables. So all fragments can then be removed. I will then replace the surface with a scaffold because then I want to use the toolbar and the bottom nav bar. Then I would like to replace observer state with mutable state observation. This is just a personal preference. There's nothing wrong with observer state. It is actually, you can use it. So if your view models are using live data, you can transform it using observer state and it'll work just fine. Then I'd like to add animations to make things look pretty and just transition very well in between the different screens as well as on the screen itself. Jetpack Compose navigation, Jetpack Compose actually provides nice APIs for animations. Then I would like to add, and most importantly, tests for all my composables. Resources. So you can find the official Compose documentation at developer.android.com/jetpack/compose. Then official Compose course, which I mentioned earlier, which I completed. This is where you can find it, developer.android.com/courses/pathways/compose. Then when it comes to layout basics, this is where you can find that information there on the Android developer website. State hoisting, which I mentioned is one of the important concepts within Jetpack Compose. This is where you can find it as well on the developer Android website. Then, as I mentioned previously, up next, TV Series Manager that is open source. And so the code is available as an open source project and part of the Google Developers Dev Library. So you can find that at devlibrary.withgoogle.com, and you can just search for up next. And you can click on the view on GitHub to see the code. And I am open to contributions from the community. Please just read my README as well as contribution guidelines for more information. I am Ahmed Tikiwa, a senior software engineer in Android at Luno. And you can find me on Twitter at Ahmed_Tikiwa. Thank you so much for having me. Open to any questions.
Any questions?
Yeah, I've got two questions. Can you hear me?
You might need to come closer to the mic, but yes, just faintly.
Speak up. You want to yell or?
There's a baby in here.
Can you hear me now?
Yes, I can.
Two questions. I like your style, the presentation. Super cool in the slides and super informative session.
Thank you.
So my question is, when we work on the XML, like when we design UI on XML, we always think about the performance impact and stuff, right? Like the concern layout, it's like if it's not like a flat hierarchy or it's like a tree, so you know what I mean. So
Yes.
we go with Compose. How does it work? Like does it do we have to think about it, or does it take care of itself?
In fact, I actually said it in one of my slides. You don't have to think about attaching to a view, all of those things, because that is part of the reason why they created Compose. They realized that if you have a like you mentioned now, a complicated XML layout, right? And if you just want to reference an item that's within it, the performance aspect of it, or the cost, is that it needs to traverse through the hierarchy tree just to look for that one item. So it goes through each node there until it finds your item. Then only can you then use set text or any of those functions. So all of that already is a performance issue. So with Jetpack Compose now, because that's why they call it the imperative approach, you now declare your UI. You literally say, this is what I want on my screen. I want a text, and you type text. So you create a composable, you say, I want a text. I want a button. I want, and that's it. So you can literally put your layouts like that, and the performance aspect is greatly better than the imperative approach. So that's the idea. They wanted to eliminate that aspect of the performance of having to have these XML layout files that can just slow down devices. So the idea is to make things quicker.
Cool, thank you. I got one, sorry, I missed that from the presentation. I got one more question based on this slide. I remember hearing about the state hoist. I missed big part of the understanding of that big part. Could you explain that one more time? Sorry.
No worries, man. So let me just try and find a slide that highlights it. Okay, so as you can see there, right, on the right-hand side, search input field, right, is a composable, but you can see there one of its parameters is a lambda function on value change, okay? And so the composable itself doesn't hold any state because it invokes on value change, which is part of the parameter there. And then the caller of search input field is the one that's then going to handle the state. So on value change then goes, rather search input field sends up that, or invokes it as an event. So because I mentioned in one of the slides that state comes down, composables, and events go up. So in this case, all child composables are the ones that are supposed to invoke an event, and that event goes up all the way to the caller. So in my case, search screen is the caller. So that's where I've defined all my my state variables. So, or rather, my state comes from the view model, but then my search screen is where it observes all of that and then passes it down to the children. So state going down. And then when the children want to do something, when there's a button click, they don't actually change the state. They say, hey, a button has been clicked. Please, can you update the state? And then that then goes up all the way. So that concept is called state hoisting, where you have the child layout delegating the state all the way up to the caller.
Cool. Okay, understood. Okay. Thank you.
Cool. Cool, man.
I have a question.
Yes.
Hey, Aris, this kid didn't touch it up. On showing dialogues, because I've been having trouble with the show dialogue stuff. Is that attached to navigation specifically, or is it not?
Showing dialogues, like alert dialogues.
Yeah.
I haven't used alert dialogues as yet, but I believe there is one actually as part of that is built into Jetpack Compose that you can use within your composable.
Okay. And it's just a regular call. It's not like we don't have to pop it into navigation, whatever. I'm a Flutter developer too, so I'm just trying not to confuse the two techniques. You know what I'm saying?
Yes. I get you, man. Yeah, so it's definitely a paradigm shift, even the way we have to think about things. So essentially, you have a composable, right? And a composable is what will emit data. So, and it emits data by calling other composables. So a composable can say, hey, I'd like to display. So in my case, I've got linear progress indicator, right? And that is something we do have in the normal XML approach. So I'd like to show a linear progress indicator, and all you have to do is just call linear. Let me just show you. I have a slide where I have it. Let me just make sure. Yeah. So
Okay.
here basically I'm saying, okay, I'd like to show a linear progress indicator, but I'd like to show it based on certain conditions. I'd like to only show it when the view model, so in other words, or rather when I have the state variable called is loading, when it's actually set to true. Then this is all you do. You basically call or define the composable here. and then your composable will emit that. So when Android is now composing or creating all the composables on your screen in the process of composition or recomposition, it will then find these composables that need to be drawn onto the screen based on certain states. So in this case, is loading that value equals true. It'll check that, cool, and then it will draw that onto the screen. And that's how it's displayed. So you can basically use that same logic. Okay, if the user has clicked on this and you want to say, are you sure you want to log out? So if is log out equals true, then you can just invoke the alert dialog composable.
Makes sense. It's just that everything else we've done before this has went against that. And it's probably because of infrastructure. Everyone else is like, oh yeah, you need to, if you're doing it in the web, you hide it, you know what I'm saying? And you grab it from some weird place. Flutter puts it in navigation. Just wanted to make sure that this wasn't doing something different or similar at least. But thank you.
Yeah. No, I get you, man. No worries. And yeah, so like I said, it's a paradigm shift. It's a different way of thinking. In this case, like in this, the way a compose is defined is that it's a declarative framework. So you just basically define or declare what you want on the screen. So above it, I'm saying I want a search area, and that's how I've defined it. I want a linear progress indicator below it. And then I've put this into a box layout. And the box layout already has got its own mechanics. So I don't have to worry about that. I don't have to worry about how box really, at least I just understand its behavior. But when I then just put my stuff in there, I don't need to worry about attaching to a view and all of that stuff. Because that was the imperative approach. I just need to define my layout and say, I want a box. Inside the box, I want a search area. Inside that, I want a linear progress indicator. So that's why it's regarded as a tool that's now making development even faster, because we're now writing less code and just describing what we want.
Cool.
Yeah. Thank you for the question, man.
Hey, Ahmed, that was a wonderful presentation, by the way. My question is regarding, you were mentioning we are eliminating fragments. So, so when these composable screens come in, how does it work? Like, how does the call stack work? And do we have something of that sort? Do we need to handle that?
When you say call stack, what do you mean?
Like when we use fragments, right? We either add to the backstack and like whenever we eliminate kind of thing, add, replace kind of thing. So how does this work for?
Yes. Yeah, so the Compose navigation will help you handle that. So it will basically create that stack for you. And like I mentioned previously, it's a different way of thinking. But essentially, these are not the same concept as fragments per se. These are basically UI elements that the Compose framework can decide whether to put something onto the screen or not based on certain state. So, and then when you then use Compose navigation, so you can then say, in my navigation, so you need to create, if you're familiar with the old way of creating a nav graph, it's kind of similar, but not necessarily in the same way. So previously you create your nav graph using XML. In Compose, you create it using Kotlin, because everything in Compose is Kotlin. So within your nav graph, you basically add your different composables. And then you then say, I want to navigate from, in my case, from the search screen to the dashboard screen. It will then handle that for you in the navigation framework. It'll basically replace the composables, decide which composable to show at a certain point in time, and then display that. Yeah. So it's a whole new way of thinking. And the idea is to just eliminate you having to think a lot about the boilerplate and rather focus on you just creating beautiful UIs. Yeah. Cool. I hope that answers your question.
Yes, sorry, she was muted. Yeah, I'm sorry. Yes, she said thank you.
Okay. No worries.
Any other questions? I was curious, you kind of showed the side by side of before and after, and the afters didn't look exactly like the befores. Is that just a result of just kind of using more of the defaults, or like I assume you could make it look exactly like the kind of other layout, given enough tweaking to the layouts, or given enough modifiers.
Yeah, you can try to get it as exactly as possible, and probably even achieve it. Like in this case, I noticed that like the material, the card within Jetpack Compose is rendered differently. So it's got a certain style to it. As you can see, the cards are a bit more nicely curved on the right hand side there, and at the bottom they're more square, and then on the left hand side there isn't that much curve, as you can see, which I could probably also achieve in the iterative approach. So I was taking advantage of these niceties that come as part of Jetpack Compose. And then yes, there was like on the show detail screen, like for example, my button right now isn't extending the full width. So that's all part of my journey as well. So I'm going to be using Material 3, which is the latest version, and then using Material U as all part of that to then try and make it even more pretty, make it even more precise or pristine. Yeah.
Great. Any other questions? I'm looking around. Any other questions from people online? If not, we got Rahul's back.
So I'm back. So I've got a question on the design, like on the design pattern kind of question. So I know that there are different components we have used in this screen. I'm trying to look for the best practice kind of approach. If I consider all this composable, and if I have to use a view model, so how will that look like? Like if will that be ideally, it should be more like individual components by itself, right? Or it should not be cluttered. So how does that work? What is the breaststroke mechanism?
Okay.
This gets
so let me see if I can
only the easiest question. Only the easy question. There's like 4 different approaches to this, by the way. There's like
okay, so yes, no worries, it's fine. So let me just share with you my, oh, by the way, the code is available on GitHub. You can probably just refer to the recording just to get the exact link. So you can see my screen, right?
Yes.
GitHub. Okay, cool. So so yes, it is. There is actually a recommended approach. In fact, they actually just released an app. I forget the name now. Now in Android. So Nia, I think that's the name in short. And so that there is kind of an opinionated guideline to creating compose apps. So even the entire structure. And within that app as well, they use modularization, which I'm not currently using within UpNext, but it is an approach which they're using in there. So in my case, and also there is a whole new architecture blueprint which they've created now, basically to be able to define your different layers properly. So your repository layer, your data layer, and your view layer or your UI layer separately and neatly. So in my case, And the way I've created it, and I'm probably going to even modify it based on that, the new guidelines. So I have my UI directory here. So I've got repository, network extensions, domain, DI, database stuff, the bindings, which obviously this is obviously going to go after I've fully migrated to Jetpack Compose. So within UI, I've got all my different screens. So all the screens that I was showing you, so in particular the search screen. So search will be here, and this is where the search fragment resides, and then search screen, which replaces search fragment, and then the search view model. And then, so search screen, this is how it looks. Okay, so this is how the top level composable, which then has the state, as I mentioned earlier. So this is where the state will be observed from the view model, and then it's passed down to the child composables, in this case, search area, and then search area is down there, search form, search input field, search results list. So the way I've done it is that these all relate to the search screen. But if I had an instance where maybe I wanted the search form to be across multiple screens, then I could create it as a separate component, which I have done. So UI and then components. So I've got image, which I've created a poster image. So I created this common one here, which is a composable I can use throughout my app. All it just passes in is the URL, the modifier, and then the height of that composable. And then it will draw it for me using the painter. It will get it, it will load it up into there. And then my composable, whichever is calling it, can then use it easily. So I'm separating my widgets and my components in a separate area. So I called it components, and then I also have widgets as well. So like the list poster card. So there I've defined it separately there. And then I can then use this in multiple areas in my app. Does that answer your question?
Thank you.
Oh, cool, man.
Well, I think that puts us pretty well at the end. Thank you again, Ahmed, for this great presentation, and happy 3 a.m. We really appreciate it. Like I know, like when we were setting this up, I saw him like, ooh, he's in a very different time zone. I'm like, are you aware of what time you will have to like, be up? And he said, it's great. I'll do it. No problem. I'm excited. And so you are very awake. I will be asleep at 3 a.m. on Friday. For anyone who's wondering. But yeah, we really do appreciate you being here and presenting virtually. And yeah, it was a good turnout. And yeah, both online and in person. So we're going to wrap up a few things here for the people in the room, but for everybody online, thanks again for coming, and we will be announcing our next meetup hopefully soon.
Thank you so much, everyone, for having me, and yeah, I really appreciate the time, and yeah, hope to see you again in the future. Thank you.
For sure.
Goodbye from the future.
Yeah.
Thank you. Bye.
Bye.
Bye.